Hello, today I want to show you how to schedule an intensive session with VieSched++, and additionally I want to show you some more options that you have by using the station-based parameterization. Okay, let's start by looking at the input files. So again, we are using the Sched catalogs, and in particular we are using the geodetic good source list for this demonstration. Please always make sure to use the latest version of the Sched catalogs. So we are trying to create a schedule for an INT3 intensive, and the INT3 intensives are scheduled using 1 gigabit mode, and you can simply select the right observing mode from the list of Sched modes, and in our case we want to use this 1 gigabit mode over here. Here you see the target signal to noise ratio that we want to achieve for each band, and we want to adjust this slightly. So for X band, we want to at least have a signal to noise ratio of 22, and for S band for a signal to noise ratio of 17. This way the observing times are a little bit longer and it's more reliable that we really get the observations. The general setup, as I said, we want to demonstrate here the creation of an INT3 schedule. So we can import the settings from the master file, from the master schedule. Let's go to the intensive master schedule and simply pick the next INT3 session which will be observed. So it should be somewhere down here. Here, this is the INT3 session that we want to schedule now. So I select this line, copy it and paste it in the input form and hit enter, and now VieSched++ sets everything up for you. So we have here the start time defined and the session code, and also the station network is selected. Yeah. So for the intensive schedule, we don't want to use subnetting, so we are deselecting this option here. Let's have a look at the participating stations. So this schedule consists of 4 stations: Ishioka, New Orleans, and 2 stations in Wetzel, so Wetzel North and Wetzel. Okay, here you can see the source list. So as I said, we are using the geodetic good source list, which contains 302 sources. Let's come to the parameterization. Okay, this time we want to create it a little bit different, and we want to create the schedule as a 2-step process. So first of all, it is assumed that scans or observations which are at the edges of the common visibility area have the highest influence on the schedule, meaning they are the most important scans to have for this intensive session. And now there are many ways to achieve this, and we want to use this 2-step process here. In order to do so, we have to change the parameters slightly. So first of all, we want to change the default station parameter a little bit, and namely we want to reduce the minimum scan time down to 20 seconds, which should be enough for these stations. For the source-based parameters, we also want to change it a little bit. We want to increase the minimum flux density to 250 millichansky per source. And for the baseline-based parameters, so we have one local baseline between Wetzel and Wetzel North, and we want to ignore this baseline in the consideration of scans, because it's most likely this baseline does not really contribute to DUT1 estimates. So let's select the Wetzel North baseline and now we want to add new parameters. And this time we want to say the scheduler, let's ignore this baseline. So we change ignore to yes and give this parameter a name. Let's call it local baseline. Hit enter. And then we simply add this setup to our parameterization. So if I go now to the Wetzel baseline, we can see that there is a third parameter available or necessary, and this is the local baseline parameter, which simply say, let's ignore this baseline for the whole duration of the scan. Okay, let's come to the weight factors that we are using. So since we want to observe every source with all participating stations, it's not necessary to add extra weight after long idle time because there will be no idle time for the stations. So let's deselect this option here. Okay, so and first step of this scheduling process is we just want to create a trial schedule. So I leave everything else like it was and simply start the scheduling process, create the schedule. It's done. And now let's have a look at the created schedule. So first of all, let's have a look at the log file. So again, as you know, error messages and only 2 warnings, but these warnings are not critical. They're just changing the 1-letter code of one station, and also it complains that it doesn't find one horizon mask for Ishioka. Okay. So let's have a look at this at the session via the VieSched++ analyzer. So let's open the created sched file. And here you can see that the total number of observations in this sched file is 220. So we get 220 observations for this schedule. Let's have a closer look. This is how the sky coverage looks like. And as I said, it is assumed that scans or observations at the edges of this common visibility area, so meaning this area here and this area here, they have the biggest influence in the for the DOT01 estimates. So what I want to do now is I simply write down the name of 2 sources which are in these areas. So here I select the source 1504 plus 377, and on the other side let's use the 0420 plus 022. So we just note the source names now here for later. Okay. So and again, if I look at the general setup, then I can see, okay, this is 220 observations. Okay, I will leave this analyzer open for later to compare it with the second step. Because what we want to do now is create our final schedule. Okay, how are we going to do that? So first of all, we want to increase the weight of these 2 sources drastically. Therefore, we add a new parameterization, so new parameters, where we simply change the weight by a factor of 10. So we'll change it to 10 times more. And we again have to give a name to these parameters. Let's say this parameter is called more weight. And now we want to get, give the 2 sources this parameter. And we start with the 1504 source, this one here. And simply add the setup. So now this source has 10 times higher weight over the whole duration of the schedule. And then we want to also change it for the second source. The second source was the 0422 plus 2, this one, 0420 plus 022. Okay, and here we also want to increase the weight, but we will start 15 minutes later. And the reason for that is, if you look at the schedule, so it starts at 7 and it ends at 8 o'clock. So, and we will start by scheduling source 1504 at the start of the session because it has the highest weight of all sources. It's most likely that it will be scheduled at the beginning of the session. If we look at the default parameters, then you see that the minimum time between 2 scans is 1800 seconds, meaning that if there is a scan to a source, then the next scan has to be at least half an hour later. So what this will do in our case is it will schedule the source 1504 at the beginning of the session and also most likely 30 minutes later. Because it has the highest weight, it will try to schedule the source as often as possible, but there is this 30-minute spacing in between, so it will scan it at the beginning and after half an hour. And the same is true for this second source, the 0420 source. But here it increases the weight only after 15 minutes, so it will most likely schedule the source at this duration and also half an hour later. So it's most likely that it will start at one side of the common visibility area, schedule sources here, Then after 15 minutes, it's forced to move to the other side of the common visibility area, schedule sources there. Then it's moving again to the other side of the common visibility area, and it's moving back again after 15 minutes. So that's the idea of the schedule. At least that's how I want to do it right now to demonstrate this process. But of course, you can be as creative as you want with the scheduling setup yourself. One final thing that I want to do is I want to change the weight factors now a little bit, and I want to decrease the weight for the sky coverage a lot, because the sky coverage is now covered by ours, forcing the scans to these two sources. Okay, now let's create the schedule and have a look at it. So it's done. So we get no errors, no warnings, everything is okay. Let's have a look at the session now. How does it look like now? Okay, first of all, I see I get a lot more observations. So previously there were 220 observations, now there are 301 observations. So the number of observations have increased a lot. And that's mainly because the sky coverage weight factor is now decreased a lot. Let's have a look at the session analyzer. So we can see now that the sky coverage looks almost the same. So we are observing almost the same sources, but the sequence in which we observe the sources have changed a lot in order to fit in way more scans and way more observations. Let's have a look at the schedule scan by scan. So I simply select 1 minute here. Now, so let's have a look at the schedule every minute. So it starts as supposed with scan 1504, and then it's scanning sources which are near this source. And then after 50 minutes, now it is forced to slew on the other direction. Maybe let's increase it a little bit. That's easier to spot. So we start by the scheduling on one edge of the common visibility, or over here. And then it's scheduling scan, adding more scans and so on. And after 50 minutes, finally it is forced to make this big slew here to the other side. But in between those scans previously, there is only very little slew time involved. Now it was forced to slew the other side, and now it should start observing stations or scans over there. And then after half an hour, now it again has to start observing on the other side. So it's again forced to schedule this 1504 source after half an hour, and after 45 minutes it should be again forced to schedule sources over here. So that was the whole idea of this scheduling, and we see that it worked out. So if we compare the sky coverage that we get here now with the sky coverage we had previously, so this was this one, if I go back and forth between those two, you see that the sky coverage looks almost the same. So it hasn't really changed a lot, but the number of observations has increased from 220 to now 301. And this is of course helping us a lot with the DOT1 estimates. Okay, so if you're happy with the schedule now, you can submit it and the station could observe it now. Of course, this was just one demonstration in how to create an intensive schedule and how you can use this parameterization to really get creative with your scheduling setup and the scheduling logic that you want to use. Okay, thanks for watching.